Okay, so I was fixing that lawn, like line trimmer, and the main problem was the polyurethane tubing was dried out and just terrible. It's all cracked and nasty. So anyway, I was kind of interested. It's like, oh, the word polyurethane, isn't that an interesting word because it has the word urea in it. Would that be a polyurea-based chemical? Who knows? Now anyway, the main point of this video isn't really about polyurethane, but we're going to use an example. It's more about how to kind of interpret modern science and also the issues of the language of modern science. It's a bit like medicine, how it's still in Latin to an extent, and medicine is simple. That's the thing. Anyone can understand and should understand medicine and basic, body care and home care and such, right? But it's made to be more complicated because it's like all this occultic science almost, and you have to spend thousands of dollars to learn it and all this kind of stuff. Chemistry is similar, physics is similar. They are always speaking about something that exists. That's what you have to understand. All this stuff is talking about something that exists. Usually in chemistry, you've got to ask the question first, is it a liquid? Is it a solid? Is it a gas? Is it a plasma? What state of matter is this in? It's talking about things that exist or interactions between things that exist. Even though they will try to trick you with all these fancy words, these are things that fundamentally should exist. Here we are with polyurethane. Now, of course, polyurethane is an industrial chemical used to make certain plastics and rubbers, and it's actually popular for foam. Mind you, pillow foam, bed mat foam, most kinds of foam are these polyurethane foams and rubbers and all kinds of things, right? It's like you mix these two chemicals together, housing, insulation, and then you get this frothy, foamy stuff that hardens. How safe is it for our health? I'm not really sure. Probably not that great, but anyway, or you have these hard, it's like skateboard wheels. Skateboard wheels are made out of polyurethane. These are rollers for like industrial purposes usually. Right, so if we look up urethane, because again, you have to understand the language of chemistry. It's very difficult. But poly means like multiple. Urethane is a chemical and is a molecule. Remember, molecules are made up usually of atoms. Atoms, if you think atoms, just think elements, because again, the scientists want to talk about all these tiny little things. They want to talk about the liver cells instead of the liver, the heart cells instead of the heart. We want to talk about the atoms instead of the elements. These are urethane, of course, is some kind of chemical compound. Here we go. Ethyl carbamate, a chemical compound which is an ester of carbamic acid. And we see here carbamate, which is the main thing, and of course that's just a name. But again, what is it? Is it solid, a liquid, a gas? If it's a liquid, is it a gel? Is it like an oil? Is it like a resin? Is it like a watery liquid? If it's a solid, is it a crystal? Is it an ash? And you've got to be questioning these things. And of course, this is a nitrogen compound. I think they call these amines. They basically make them. Here we go. The salt of ammonium carbamate is generated by treatment of ammonia with carbon dioxide. So we see here, this is a chemical equation for ammonia, and as I said, these are atoms. So it's two of these. So you would have maybe like two different, maybe we'll look up ammonia, right? So it's two of these NH3s, which again, it's all language, it's all symbology. This isn't real. This is a fantasy. It's not real. It's a symbolic representation for what we are talking about. The same way, my words are just words. They are only real so much as you are hearing them. I'm not creating physical things through my words. I wish I could, one day maybe I can. Like the word apple is just a word for an apple. It makes you think about an apple. It makes you control your mind, to think about an apple, but it's not an apple. So again, two of these NH3s, and of course the H3, the little 3 here just means 3 of the H's. And it's nitrogen and hydrogen, so I assume that's ammonia. I'm going to assume that. Here we go, NH3. Right, and then I guess different NHs are, different states of it, I don't know. And then CO2. We all know about carbon dioxide, CO2, the stuff apparently we breathe out. You get a salt, and again, a salt is a state of matter, right? It's a state of physical materials. They say acids a lot. They say acids, and acids mean anything acidic. Don't confuse an acid with a liquid that's acidic. It's not always a liquid. Citric acid is a crystal. It is an acidic crystalline substance that you can make from citrus. Nowadays they make it from mold. It's kind of a nasty process, but So there are different kinds of things that you have to learn. And of course this, they say ester. Ester is like an oil. And you see how it says ethyl carbamate. Esters, they usually have like ethyl, butyl, methyl, and then they have another attachment to it, so to speak. And these things are like oils, sunflower oil, rice oil, lard, butter. These are complicated esters. They're like big esters, and you make them, I think, from like a certain acid, certain acidic things mixed with certain alcohol, as you can see here, ethyl, and then they make an ester. I'll have to do some stuff on that. That's how you make, quote unquote, what you would call the oil of a metal, or the ester of a metal. Anyway, so again, then we have polyurethane, which is the poly version of this. And I told you, ammonia, all these amine chemicals, and amine chemicals, like it's got a nitrogen in it. Anything with the nitrogen is usually related to urine or waste, organic waste. And again, you've got to think organic chemicals are these things which are usually made up of oxygen, carbon, nitrogen, hydrogen, and they're like your 4 elements. Hydrogen being the water, carbon being the physical, nitrogen being the air, it's mostly what the air's made up of, and oxygen being the fire, because you need oxygen to burn, right? Hydrogen's water because it's, H2O, right? And carbon is earth, because what is, solid carbon is like a black, very earthly substance. So polyurethanes are produced by reacting diisocyanates. And again, you've got to understand the chemical terms. Di means 2, so it's 2 isocyanates, as in like it's 2, I think like molecularly or something. And if you want to understand the molecular science, don't think about it too much. And polyols, and I'm pretty sure polyols are the polymerization chemicals, so that are made out of like minerals and something like that. And the isocyanates, I think, is the amine, and it says isocyanates are usually produced from amines by phosgenation, treating with phosgene. And again, all this stuff, phosgenation is a process. Again, in chemistry, everything is a process or a processed. A process or a chemical, right? So this is chemicals, but the process is plussing them together and then turning them into this, right? That looks like, was it hydrochloric acid and RNCO? I'm not sure what the R is. Here we go. Upon treatment with an alcohol, an isocyanate forms a urethane linkage. So one interesting thing, if you think about plastics, a lot of the states that they're in when you make them is like a syrup or an oil. And I think certain volatile alcohol-based chemicals, I'm not exactly sure. It's a bit like if you have epoxy, you mix these 2 syrups together, and then you have this liquid thing which is like full of like ketones and esters and all these like weird things that I have no idea how they figured this stuff out, right? And then they mix this it's like a liquid, right? Like a sweet, sharp smelling sort of volatile liquid, and then it hardens. It's crazy, isn't it? Just hardens like. So the syrup hardens, because if you think about plastic, I got this piece of plastic in front of me. It's just like hardened oil, hardened resin. That's what you got to really think. You got to look beyond. Look at all these words: isocyanate, functional group, polymer, cyanate, like all these complicated words. Look beyond them. Phenyl isocyanate. Again, once you learn what this stuff is, phenyl is obviously a organic chemical, and assumingly this is some kind of, is it an ester because it says phenyl isocyanate? I'm not sure. So would it be in the state of like a liquid, like a syrupy, oily liquid maybe? Look beyond this and try to understand what is the physical thing that it's talking about. What is the real thing that it's talking about? And a lot of this stuff, I think the issue is it's coming from factory, like science, because you've got to think, where does science come from? You'd think it comes from research, and to an extent it does, and from nature and all this, but it comes from factories, right? Factories manufacturing this stuff. This is how they figured probably a lot of it out. You've got chemists working for these factories. They're creating polyurethanes and polyesters and all these kinds of plastics, and they don't really want to tell everyone how this shit works, because then they lose their market. At the end of the day, this stuff is made for the sake of money, right? It's made to make money. Here we go, yeah. Usually carboxylic acid is, when you're talking about esters, everything's like carboxylic acid. A carboxylic acid with ammonia and a hydrozoic acid, okay, yielding isocyanate. And of course, if you need more explanation on this stuff, you can look it up on, you can use an AI tool like the Gab AI, which I have here, which basically tells you it's a polyol, which is a type of alcohol with multiple hydroxyl groups, and a diisocyanate, which is a substance containing two isocyanate groups. Yep, we said that. The combined through a chemical reaction create a polyurethane resin, which can then be processed. Okay, and then we type is diisocyanate and ester. We'll do, here's a little tip. So you do number 1 is diisocyanate and ester, and then we do number 2 is diisocyanate in the physical form of a liquid like an oil or syrup. Here we go. It's not an ester. Blah, blah, blah. In contrast, it contains okay, it's not really telling me what it is. You have to kind of like, push it a little. Different physical forms, including liquids and solids. So we can assume it's not a gas unless you heat it up. The physical state depends. It's giving me. See, again, too much bullshit. This is when you talk to a scientist and you kind of realize, you have no idea what you're talking about. You're not talking about real things. I want to know what this real shit is. It says they're all in the form of liquids. Viscosity can vary, but they're not typically as viscous as oil or syrup. Okay, whatever. So it's saying it's just like a liquid. Again, you could ask it more and more questions to really understand this. But anyway, I have this little video here. Just go into it.
Polyurethanes form another class of polymer compounds. Let's first look at how these are synthesized.
Each reagent must be weighed out carefully. The pre-polymer consists of toluene, diisocyanate, and castor oil.
So it just said toluene, diisocyanate. Toluene is a mineral product, and then it said diisocyanate. And they also said castor oil. Castor oil is an oil made from a bean, and you notice how thick and syrupy that was. That's because that is, castor oil is very, it's like that. That's what gives it its thickness. Why they're putting in castor oil, I really don't know.
Glycerol and castor oil are added next.
And glycerol is like a sweet substance. They make it from, it's a bit like similar to making soap, I think. You make glycerol, you can look it up if you want, and it's like a sugar syrup in consistency.
Once the reaction begins, these will form an extended polymer network with the pre-polymer.
So one thing I've always had an idea on is like polymer, it almost relates to sugar, because toffee, when you heat and make toffee or caramel or something and you make it like really tough, it is essentially just like plastic. So I'm wondering, is there some kind of interaction between that where somehow like they're making mineral based sugar or something? I'm not sure.
The mixture is stirred. Silicone oil, a surfactant, is added. Then the catalyst, tin octanoate. Again, the mixture is stirred.
Tin seems to be used a lot as a catalyst. I have no idea how they figured that one out.
Finally, water, a foaming agent, is added. After the mixture is stirred, the polymerization reaction takes place. As the reaction proceeds, carbon dioxide gas is released, giving the product a foamy texture. Polyester triols and diols are used in the manufacture of commercial foams to make mattresses and cushions.
Okay. So you can see there, it's starting to foam and eventually it'll harden. So you'll have, again, like if you know about insulation and if you ever just played around polyurethane foam, it's just this like foamy, hard, weird kind of stuff, right? So it's pretty interesting that all that stuff makes that, you know, and then different mixtures will make different, you know, you got this rubber, you got this other stuff. But anyway, the video, as I said, it's not about polyurethane. It's about trying to give you an idea on how to interpret and understand and to analyze this stuff, because it's very complicated. If I created this language, I would have brackets which would say the physical state, characteristics about it, and, you know, all that kind of stuff, like maybe what it's created from. But at the end of the day, I don't know, like maybe industries don't really want people realizing that like polyurethane is like piss plastic, essentially. I mean, look at the colors of it. I always thought it was a bit suspicious how cream yellow this stuff looks. It's a little bit too ammonia-ish. Yeah, if anyone used Gorilla Glue or like that kind of urethane glue, it's good stuff. But yeah, I always thought it was weird, suspiciously coloured. Like, why is it always kind of yellowy? Why does it crack and rot in that weird way? What's going on with this stuff? And well, lo and behold, urethane. Now, of course, they do make ammonia by this interesting, crazy process, which involves, I think, electricity and pressure and all this chemistry equipment, and, you know, it's made from the air, essentially. I think the Germans figured it out during World War II or before it. I'm not exactly sure. But otherwise, yes, they could make it also out of urine and other things. Now, if you want something to research, I researched PLA, which is this stuff, the 3D printer material that makes these little figurines, right? Because it's polylactic acid. And again, lactic acid. Lactic acid, I believe, is the acid form of lactose. And then it's just a poly, it's a plastic. And the way they make this is actually really weird, because it's manipulation of physics and chemistry in reality in its absolute cold, or not absolute, but, lots of cold, lots of heat, lots of pressure, lots of vacuums, lots of just all kinds of crazy things, all these different chemicals, and then they create this this material, which apparently is a bit more environmentally friendly, which is good. I think they make it out of corn. But of course, you could make it out of milk, I think, as well, because it's lactose, lactic acid. Yeah, it's weird as, man. Chemistry's weird as. I don't know how people figured this shit out. It just, to me, sometimes it looks like witchcraft, like sometimes, even when I try to understand some of it and really look it up, it's just a bit, I guess it really is like manipulation of the physical world in its absolute, and the more, again, pattern, understand the patterns to everything in life, and then you'll understand, chemistry, physics, occultism, mathematics, whatever you want, because it's all, you're just trying to realize what the overarching pattern to everything is. And even these things is a pattern to the language and, what they are and such. Like, as I said, acid, it's an acidic thing, right? There you go. There's one of the patterns. So, anyway, that's about that. Hopefully you kind of got the idea and hopefully gave you some good information. Of course, check links in the description for social and commercial stuff, and have a good day.